Hi, and thanks for coming along to the session today. In 2018, the Cloud Foundry community picked Istio for traffic routing in its new Kubernetes runtime. I'm here to tell you about a few things we've been working on since then and how we see the project improving in the next few quarters. My name is Craig Box, and I work on the Istio team at Google Cloud. I joined Google in 2004, and one of my first work trips was to Seattle, where I heard about this Project 7 thing that we were working on. I've been involved in Kubernetes and Cloud Native ever since, helping our customers, field sales teams, developers, and the open source community. I've been working on Istio full-time this year, as well as continuing to host the weekly Kubernetes podcast from Google, which I encourage you to check out if you're interested in keeping up to date with the Cloud Native ecosystem. To start with, I'd like to give an overview of the way we run the project. I should provide the usual disclaimer. Open source projects serve at the pleasure of their contributors, and this has been a very difficult year for everyone around the world. This talk will give you an idea about some directions the project is pushing in, but we haven't yet built a formal 2021 roadmap. What we're planning to do is a lot of work on fit and finish of the work we started in 2020. Roadmaps are very bottom-up in Istio, so if we're missing something that you need, then please get involved with one of the working groups and propose it. This year, we've had some changes to the governance of the project. You may have seen the news a few months ago about the Open Usage Commons. This is an entity that Google bootstrapped to be independent steward of open source trademarks, including the word Istio and its sailboat logo. This gives assurance to projects like Cloud Foundry that build on Istio, and vendors who make Istio available as a service, that the trademark is free and fair to use. We also made some changes to the project governance this year. There are two groups that are responsible for aspects of the Istio project, the Steering Committee and the Technical Oversight Committee. Steering handles administrative, advocacy, marketing, and governance functions, such as running events and administering our code of conduct. As the project continues to grow, we're looking into establishing subcommittees in these areas. Steering was created to allow the Technical Oversight Committee to stay focused on the technical and design aspects of the project. The two groups are staffed differently. TOC is formed of individuals who have demonstrated leadership in the project through participation in working groups, where the bulk of project decisions are made, and then serving as working group leads. If a member moves company, they retain their seat. There are 7 members on TOC representing 4 different companies. Steering was originally formed of companies who have invested in the Istio project, proportional to their contribution. We still think this is an important thing for a project to have, to provide direction from those who are invested most in the project's success. But to this, we've added elected community members. We now have a 13-member steering representing 7 different companies, and I am a member of that group. Similar to SIGs in Kubernetes, product and engineering work in Istio is done in working groups. We currently have 8 such groups. Networking, policy and telemetry, and security are the 3 core functions of a service mesh. The other groups cut across all these functions, with environments handling installation and integration with user workloads, and service discovery systems, so possibly the most relevant to this group. Istio went 1.0 in July 2018, which was the signal that we thought the project was ready for serious production use. In fact, we know that some people had been using it in production since version 0.2. What that emphasizes to me is that Istio was effectively feature complete right from its earliest stages. It was able to come out of the gate fully formed, so to speak, because it built on the internal API infrastructure at Google Cloud. The Amalgamate project from IBM, which was an early service mesh focused on traffic management, and the high-performance Envoy proxy, battle-tested at Lyft. Of course, no plan survives contact with enterprise users. 1.0 had performance and scalability issues, and it took a bunch of re-engineering and a 9-month gap to get 1.1 out in March 2019. Since then, the project has maintained a quarterly release cycle, and we're looking to do the same into 2021. Now, just a moment ago, I said that the core functionality was all present at 0.2. Some products build a proof of concept of one feature, get it production ready, and then add a proof of concept of another feature, and so on. Istio had all of its major functionality in place at the beginning. Of course, not all these ideas were perfect, not all of the APIs were final, and not all of the implementations worked at scale. Since then, we've largely been focused on iterative improvement, with a couple of tentpole changes. Let's have a look at those, starting with extensibility. Istio provided for extensibility from day one, implemented by a component called the Mixer. Mixer allowed custom adapters to act as an intermediary between the data plane and policy or telemetry backends. It added overhead to requests because it required extensions to be out of process, and that overhead was a problem for many of our users. To get the performance we wanted, we needed to move that functionality into the proxy. First, we built new authentication and authorization APIs, which are implemented directly in the Envoy proxy server. This means that for common use cases like RBAC or checking JOTs that you can express in the API, you don't need to call out to the Mixer to check each request. Next, we built support for exporting Istio's metrics to common services, most notably Prometheus, as extensions to Envoy. By removing Mixer, we were able to get substantial decreases in latency. The green line on this graph was P99 latency when running with both client and server proxies. The purple line is the same setup without using Mixer. We still need to provide a way for people to extend Istio to connect their own access control systems, quota or auth systems. We've achieved that by building a WebAssembly runtime into Envoy. WebAssembly, or WASM, is a portable bytecode format for executing code written in multiple languages at near native speed. It is a well-supported client-side technology, and that gave us confidence in making a strategic bet on it on the server side. Our implementation uses the runtime built into Chrome's V8 JavaScript engine, but the spec allows running in others, including null runtime, which compiles the extension natively into Envoy. We built a generic ABI for embedding WebAssembly in proxies, which means compiled extensions will work across different versions of Envoy, or even other proxies should they choose to implement the ABI. For developers, we've built SDKs for extension development. We started by targeting C++, Rust, and a JavaScript derivative called AssemblyScript. We've been working on this for almost 2 years in the fork of Envoy, which is what we've shipped with Istio during that time. Some very good news this month. WebAssembly support has landed upstream in Envoy, and with the ability to move any remaining custom Envoy code into extensions, we'll soon be able to ship upstream Envoy with Istio, and no longer need to maintain a fork. The second major change for the year was around how we package and run our control plane binaries. In the original architecture, we separated the concerns of our operators by taking the functions that make up the control plane and running them as separate microservices. This was motivated by Google's experience running a service like this at scale, but it made it hard for our users to coordinate or upgrade in the most common use case, where people were only running one of each service. First, we removed the Mixer, as we've discussed. And then we took all the rest of the components and consolidated them down into one service. Some people have said that this is going from microservices back to a monolith, but we still think of Istio-D, the new binary, as a microservice, one that's still architected so you can replace its internal components with external systems, should you need to. The move to Istio-D was just one change motivated by the wish to make installation, upgrade, and operation of Istio orders of magnitude easier, coordinated by our environment's working group. It used to be very complicated to install, not least because there were so many components and configuration options for it. Generating Helm values files was complex, so we moved to a CRD called Istio Operator, which you can install in one of two ways. You can use Istio-ctl install to create the mesh, or you can run a controller that consumes that same resource and runs in your cluster. Which method you use depends on whether you want to have the administrative credentials required inside or outside the cluster. For that reason, we recommend the former method. People also want pure Helm support, and there are some unsupported methods to use it today from the old Helm 2 chart days, but we're adding official Helm 3 support, scheduled for the upcoming 1.8 release. This simpler model has made upgrading easier and safer. For example, you can canary your control planes by deploying a new version of Istio D alongside an old one. We've also had a major recent focus on extending a mesh outside a single cluster, both with multiple clusters and services that aren't running in Kubernetes, usually on a virtual machine. There are many different ways you could do multi-cluster, clusters on the same or separate networks, each cluster having its own control plane, or one control plane supporting multiple clusters. By simplifying the control plane and improving our installation methods, we've been able to consolidate our instructions and have drastically simplified multi-cluster in the upcoming 1.8 release. Likewise, we want managing a workload that's on a VM to be as easy as just installing the proxy on it. Earlier this year, we introduced a new API that lets you refer to workloads that are running on VMs, which makes it easier to migrate workloads between VMs and your Kubernetes environment. You could add entries to our service registry by creating a service entry object, which listed the IP addresses of VMs that implemented it. It was possible, but complicated, to route traffic to pods and to VMs at the same time. More so if you wanted to add sidecars to those VMs as you onboarded them onto the mesh. We didn't have an object which lets you set the properties of a VM sidecar, or respond to lifecycle changes or health checks where an address was not ready to serve. We added a new object to help here. A workload entry allows you to describe non-Kubernetes endpoints that you want to add to the mesh, and then treat them the same as a pod. It makes it easier to enable mutual TLS between workloads, containerized or not. Now, you can use a single service entry to refer to pods and workload entries, using the same label selector logic you do for pods alone. We're working hard to make it possible to have VMs and pods coexist without any configuration needed to bridge them together. The VM case poses another problem. How do you have your VM be aware of the services that are running in the rest of your mesh? VMs don't pick up the entries we create in Kubernetes as DNS, and it's not necessarily secure to use that DNS from outside the cluster. So, in 1.8, we're introducing smart DNS proxying. This will reduce load on your DNS servers, give you faster resolution, and allow you to access services from VMs without having to expose the kubedns to them. You can also use it to resolve Kubernetes services on any cluster in any namespace without the need to create stub services in every cluster. Let's look at an overview of what our other working groups are progressing on. The Policies and Telemetries team has two focuses. They want to make it easy to manage the telemetry coming from your applications and use that to make decisions about traffic management or scaling that can be fed back into the system underneath. At a lower level, you also need the ability to monitor the Istio components, and work continues to improve the ease of understanding of the mesh itself. With the new extensibility model that we mentioned before, we're allowing people to easily add new behavior to Istio. We're helping the community of people who have already built third-party extensions with the Mixer API to port them to run as WebAssembly inside the proxy. We're also working with the community around WebAssembly to support a distribution method for first and third-party services. For example, Solo.io have built a WebAssembly hub in the vein of the Docker Hub, and we expect to see more support for artifact management tools for WebAssembly packages over the next 12 months. Security remains a high priority for Istio. The service mesh feature set lets you move firewalling away from the edge and secure every workload, so we're excited to continue to improve Istio's security posture. Recent changes have included moving to Envoy's secret distribution service, instead of mounting services through Kubernetes volumes, which makes them easier to rotate. In 1.8, we're also supporting integrating custom certificate issuers with Istio, where they issue a certificate to Istio D, which then acts as a registration authority. This release also adds a mechanism to securely integrate a VM into a mesh by provisioning the mesh identity for the VM based on that VM's platform-specific identity, especially suited to cloud instances. Our user experience working group has done some great work. They drive development in Istio CTL, so before installing a mesh you can validate your configuration, as well as understanding how the configuration is sent around the proxy servers that make up the mesh. They are working hard on troubleshooting because there are necessarily a lot of moving parts in a mesh, and we want to be able to quickly count things in and out in the event of an application misbehaving. In the near term, all functionality currently exposed by Istio CTL will also be accessible via documented and supported APIs. This will allow integrations beyond the Go ecosystem and provide tight contracts for testing each release. Likewise, the documentation group is aiming to help administrators and mesh users by not only making it easier to learn how to get started with Istio, but how to perform those day 2 tasks and how to debug the mesh. This is an area where the power of Istio has traditionally been shown to people very early and thus confused with complexity. We want to make the easy things easy and the hard things possible. But this is an area where a lack of experience in the product is a net benefit. So if anyone out there wants to get involved in improving Istio's documentation, the project is always looking for more contributors. A thread running through all these improvements is the idea of the right tools, documentation, and API for the right use cases. When you're running a mesh at scale, you're likely to have application teams, security teams, network teams, etc. It's important to be able to expose controls to those groups that make sense. For example, the Istio APIs separate gateway configuration, which is usually controlled by a network administrator, from options that a service owner might want to configure based on how they would like people to communicate with their service. Those parameters, like load balancer algorithms and connection pool settings, are set on a destination rule object, which can be managed by the service owner. Istio is designed to work well even in a default use case, and so if you don't need to customize anything about your traffic control, you don't need to create destination rule objects. We're excited to see the work happening in Kubernetes around the service APIs, a new V2 of ingress, if you will, which has taken lessons from the traffic APIs inside Istio, as well as from other projects. These are experimental APIs, so we introduced experimental support for them in Istio 1.6, so you can get a feel for what it might be like to use them. In closing, while we don't have a formal roadmap as such, you can get an idea of what would go on it by looking at our planning docs for 2020. In 2009, Apple put up a slide at the developer conference touting that their new Snow Leopard OS had no new features. We have a good foundation to have a Snow Leopard year of our own. We have a lot of alpha and beta features to get to stable, a lot of production users who give us direction on rough edges they hit, and a partner community such as yourselves who are building on top of Istio. Our goal is to help everyone get a stable environment, continue to work with our users to remove blockers and smooth rough edges. If you'd like to get involved, please check out the community section of our website, where there are links to Slack, our discussion forums, GitHub, and more. You can find both myself and the Istio project on Twitter. Thank you very much for your time. Hi, I assume I'm live right now. It's very hard to tell. I don't have any visual feedback, but thank you very much if you did watch the talk, and I have a little window here where I can see any messages. So if you'd like to send some, if you have any questions, I'll be around for a couple of minutes and would love to answer them. If not, we can talk about this cup of tea. I'd like to take a moment to thank the Cloud Foundry community for actually having their European event in a European time zone. Very refreshing. Normally, it's quite early in the American day, and people look at me and saying, "What are you doing having a cup of tea?" I say, "Well, that's just tough." I say, "You can have a beer at whatever time you want, but at the end of the one's workday is the start of somebody else's." Could someone just drop something in the chat to at least let me know if they can see and hear me? Not promising. There we go. Perfect. Thank you very much, Troy. Now, my question to you is, do you have a question for me? Any general feedback on the presentation is welcome. Anyone saying, I love listening to you, I'm going to go subscribe to your podcast, that's also welcome. This is an Earl Grey tea. Anyone has a suggestion of favorite flavors, feel free to throw that in the chat as well. Are we all very excited for CF for Kate's 1.0? Great release. Shame about the name. A lot of letters. I think the Q&A is where I would create questions. Let's give that a go. Yes, I think I understood the difference between kubecf and CF for Kate's at one point, but never 100% sure. All right, we do have a real question here, a vague question. What is the relationship between Istio and the service mesh interface project? Does Istio fully implement it? The answer is Istio does not implement the service mesh interface at all. It's an external proposed standard. To be honest, we've not seen uptake. We've not seen people asking us for it. There is an adapter that was written by one of the teams, contracted out by one of the teams who created SMI to a European company to build. So it is possible to configure Istio using this adapter and the SMI, but I have no concept of how up to date that is, whether that's kept up to date. And to be honest, we think that the Istio API is built at the right level, as I said in the presentation. And the SMI is likely to end up being a lowest common denominator, where it will try and implement things that apply to multiple service meshes and not give you the best opportunity to use the functionality built into the one that you're using. It's also tough because I want to say 9 out of 10 service mesh products use Envoy as their engine. Linkerd is the main holdout. They have their own proxy written in Rust. And so there will be some things which you can express in SMI that will be presumably reasonably Envoy specific, and it will be hard to assume that you'll get the same functionality out of that. Similar to, for example, the APIs between Kubernetes and Mesos and so on, or even going back to VMs, things like Scalar and things that tried to abstract away the difference between different cloud providers. We don't see that any of them really picked up a lot of traction over time. It still seems I'm the only person who can use the Q&A feature here, but the correct answer is Earl Grey is the best flavor of tea, if anyone was paying attention. Lovely. All right. Well, I will wrap this up now. If anyone has any questions, I'm at CraigBox on Twitter, and I'm very happy to answer going on. Thank you very much.